All right, good afternoon, class. So you guys should have submitted your compound inequalities worksheet, and you should have opened the absolute value inequalities notes. Just a reminder, we're going to go through the notes today. Tomorrow, then, I will be back. We'll do a few examples, and then you guys will have work time on your homework assignment. So the homework assignment that goes along with this is not due until Wednesday, okay? All right, earlier this school year, we learned how to solve equations that had absolute values in them. This is something that, in all honesty, you guys have kind of struggled with. And so hopefully, maybe now that this is the second go around, it'll go a little bit better with it. But remember, when we take the absolute value of a number, it's really the distance the number is from zero. So absolute value is always, always positive. So for example, if I were to ask you guys, what's the absolute value of 7? You would tell me that's 7. What's the absolute value of negative 7? You would say 7. So when we're solving, we don't know exactly what this number is inside the absolute value. We don't know if it was a positive 7 to start with or if it was a negative 7 to start with. So that's why anytime you see absolute value bars and you're solving the equation, there are always going to be two answers. For every single one of these, there's going to be two answers to them. When we did this lesson, it was right around the holiday time, and I remember talking about as far as, think about those absolute value signs. It's like a present. We don't know if that present is a really, really good thing. It's a positive. It's that Xbox. It's that new iPhone. It's the cute shoes that you've always wanted or something. It could be that. Or, remember we said inside that present, could be those like pair of socks, that underwear or something, or like something you just really don't want kind of thing. But you have to like have a okay reaction with it and kind of prepare for both. So because we don't know what's inside the present, we have to do both situations to kind of prepare for both. So these steps that we're going to go through here are identical to the equations that we solved that had absolute values in them around the holiday time. There's one thing that's different as we look at what's called case 2. So our first thing that we always do is we have to isolate the absolute value bars first. We want that to be the only thing on the left-hand side of our inequality sign. Only once this is done can we move on to step 2. And in step 2, we're going to set up two cases. Case 1, we assume that it's a positive. This is our good gift that we want. Okay? So we're going to assume that one, we're going to assume that the number's a positive, solve, and go from there. Our second case that we're going to set up is we're going to assume what's in the absolute value is a negative number. So this is our, I'm going to make a note here, this is our bad or like icky gift kind of thing. These are quotes here, sorry. So when we assume that negative situation, there's something important that we have to do. When we take this second case here, when we did it earlier in the school year, all we did was change the number on the other side of the equal sign to a negative. Same thing here. When solving for the negative one, we have to make the number be negative, and we have to switch the inequality sign. So I'll show you what that means. So you have to do this. This is a big thing to remember that students need to do. A lot of students remember the first part. They will forget this second part here. Okay? And just like what we've been doing with all our other ones, we're going to be solving and graphing each one. And you're going to have two answers. So we're going to graph these so they're on the same number line. So let's take a look at this first example. So what we want to do first is I'm going to draw a line through my inequality. I want to make sure the only thing on this left-hand side of our inequality symbol, I want to make sure that the absolute value is the only thing here. It is. There's stuff inside of it, but there's nothing outside this absolute value. Okay? That's a really good thing because now we're going to split it up into our two cases. So case 1, and then we're going to split up into case 2. In case 1, we write this inequality exactly as it's seen. We just drop the absolute value. So case 1, you're going to solve it exactly as it is. I'm just going to solve it right away. So x is less than or equal to 15. Again, this is one solution. There are always two solutions for absolute values. So I need to set up the other case. This case is when we're dealing with a negative. So I'm going to write the inequality exactly as I see it, drop the absolute value, but I'm going to flip the inequality symbol, and I'm going to make that be a negative 12 instead. So when we split up into the two cases, absolute value symbols go away. In the second case, again, notice what's inside the absolute value stayed exactly the same. The only thing that changed is the inequality symbol is flipped, and we have the negative number for our absolute value, meaning the number that's on the other side. And then we solve this. Careful with your math. I'm starting to notice some of you guys, I think you're just going too fast, not using a calculator, and that's where you're making your mistakes. Careful with your math here. This should be x is greater than negative 9. So these are two answers. You will always, always come up with two answers when it's an absolute value, every single time. Now let's graph them. I'm going to put the two numbers on my number line. And again, pick some other number to put on it. I don't care as long as it's in the right place. So I'm just going to put in 0. For this one, I want to graph x is less than or equal to negative 15, so close circle, shading in the smaller direction. This next one is x is greater than or equal to negative 9, so close circle, and because it's greater than, shading towards the middle. I will give you one hint on these. As you're graphing them, you're either going to shade in the middle or you will shade out. These end up being a compound inequality of sorts. Okay? But here are two answers for this one. If you guys have questions, help each other out on this one. All right, let's take a look at this next one. First thing we always want to look at, line through inequality. Is there anything else outside the absolute value on this side of the inequality? Hopefully you're saying no. So that means we could split this up into our two cases. But do you guys notice this is a number that's a negative 8? When we talk about absolute value, we said absolute value is always positive. So what we want to look for with these is any time that there's a negative here, this will automatically result in either a no solution or all real numbers. One of the two. So we have to figure out when is it a no solution and when is it all real numbers. So here's what I want you guys to think on this. This here, and I'm going to kind of make notes with this. This is always positive. So if that side is always a positive number, can this ever be smaller than a negative 8. So again, think about this. This side is always going to result in some positive number every single time because absolute value makes a number be positive. Can this ever be smaller than negative 8? And my hope is you're saying no, because you have to be bigger in order to be bigger than negative 8. To be positive, I should say. So this is an example of a no solution. So this can't happen. So it's a no solution. And I'm going to write an explanation on here so you can see, have like kind of notes as far as why this one's a no solution. So this is a no solution because absolute value can never be smaller than a negative number. So again, because we have a negative here, that we're not even going to go through and solve it all. Because this is a negative, this will always result in a no solution or all real numbers answer every single time. How we decide which one it is, we will see an all real numbers one later today. How we decide which one it is we think this side has to be positive. So is a positive number ever less than negative 8? If you say no, that can never happen, that's a no solution. If we were to able to at some point say yes to this, that would be an example of an all real numbers. And again, we'll see one of those at some point today. But this one, the absolute value can never be smaller than a negative 8, so this will never work. This is probably the hardest part for kiddos with these. So if you can kind of find a way to, some students have recognized anytime you see the less than sign, like you have absolute value is less than a number. Oh, I should say less than a negative 8. Or less than a negative number. This will always be a no solution every single time. Okay? If you guys have questions, see if you guys can talk about it, help each other out, because again, this is kind of the tricky part. We'll practice more of this for sure tomorrow and on Wednesday. All right, let's take a look at example C. So first thing, line through inequality. Is the absolute value the only thing on this left-hand side? It sure is. So I'm going to be thinking, splitting apart this into the two cases. Let's check. Is it on the other side of the absolute value? Is it a positive number? Yep, that it is. That means I can for sure split into my two cases. Remember, case 1 is our positive situation. So we basically write everything as it is, but without the absolute value bars. And then case 2, again, is where you work with the negative option. So you write everything exactly as you see it without the absolute value bars, but you flip the inequality and you make it be a negative 9. Now, some students after that last example, they'll start to say, Mrs. Haugen, we can't do this one because it has a negative here. That negative number is only in the original problem. Once you split into your two cases, that will automatically mean you have two solutions and you need to solve both of these. Okay? So we're only looking for that negative number, the very, very original. So this one checked out, so we're good. Here's what I would like you guys to do. I would like you guys to solve both of these, and I would like you guys to graph them. So go ahead and press pause. When most people are done, go ahead and press play. We'll compare my answer to your answer and see what questions you guys have from there. So go ahead and press pause, and then press play when most people are ready. All right, here's what you should have for your answers. Solving case 1, where again we had it worked out as a positive, adding 3 to both sides, and then dividing by 3, you end up with y is greater than 4. You'll notice on my graph that I have 4 here, open circle, shading towards a bigger set of numbers. Case 2 again is our negative one, where we had to switch the inequality sign and make it equal to a negative number. Same thing, adding 3 to both sides, dividing by 3, so you end up with y is less than negative 2. So I have an open circle at negative 2 and shading towards the smaller numbers. If you guys have questions about the solving ones here, press pause, help each other out so that way everyone can kind of understand where we're going. All right, so on this one here, let's take a look at this one. Line through inequality, checking to make sure that the absolute value is the only thing on this left-hand side. It is. And I want to check to see, is this a positive number? Shucks, this one's not positive. So again, this negative tells us that our answers will be no solution, or it could be all real numbers. Okay? All right, let's think about this. Again, the absolute value, this number is always positive. So if I want that to be greater than or equal to negative 11, could this ever happen? Can any of you guys think of a number that's bigger than negative 11 and positive? Hopefully you guys are listing lots of them. There are a ton of numbers bigger than negative 11 that is also positive. So because this could happen, we could actually find numbers to make this be true. This means that our answer is all real numbers. And again, you won't need to explain on your homework, but I'm going to put it in here as far as why it can be all real numbers, or it is all real numbers, I should say. And I'm going to put because the absolute value will always be bigger than a negative number. So again, all real numbers, because the absolute value will always be bigger than a negative number. Unlike our other one, the absolute value could never be smaller than a negative number. So this one works because we can think of numbers to make that be true. Again, if you want to make like kind of a cheat note like we did before, anytime you have the absolute value of a number and it's greater than a negative number, this will always result in all real numbers. As long as you see that greater than sign with your negative, it's going to be all real numbers. If it's a less than, then it will be no solution. Okay? Again, those negative numbers can be tricky. We will practice some of them tomorrow and on Wednesday. have a short discussion, see if you can help each other out if people are stuck and they're kind of confused with this. So that way, hopefully, it'll help you as you're moving forward. All right, now let's take a look at this one. Line through inequality. Here's my absolute value. Is there something outside that absolute value that's on the same side? Hope you're like, Mrs. Haugen, yep, there's a -3 there. We need to get rid of that first and move it to the other side before we can split into our two cases. So to undo a -3, we're going to add 3 to both sides. Cross out what we got rid of. So I have absolute value 2x plus 1. It's greater than or equal to 9. Now, if I look at my absolute value, it is the only thing on this left-hand side. So we are going to be able to split into our two cases at this point. So you're going to have case 1, which is your positive, and case 2, which is your negative. Setting this one up. So 2x plus 1 greater than or equal to a positive 9. And rewriting it, but to a negative, less than or equal to a -9. And darn it, I found one mistake. Do you guys notice here that when I was rewriting my cases, I put in the absolute value symbols? Those should not be there. When you're writing down your two cases, you do not want to write the absolute value symbols because that will get confusing, especially in our second case. From here, I know that you guys are able to solve these ones. So I want you guys to go ahead and practice solving them. When most people are done, go ahead and press play, see if my answers are correct, and then we'll move on to another example. So press pause, and when most people are done, press play to see if we have the correct answer. All right, taking a look at this one. In case 1, subtracting 1 from both sides, 9 minus 1 is 8, dividing by 2, so x is greater than or equal to 4. On my number line, 4 is on my right-hand side, closed dot, shading towards the right. Case 2, same steps, minusing 1. Again, be careful in your math on this one. I can't tell you how many times students gave me the wrong answer on your recent homework assignments with math mistakes like this. Okay? Dividing both sides by 2, we don't need to switch the inequality sign for our answer because we divided by a positive 2. So then x is less than or equal to a -5. If you guys have questions, help each other out, make sure that everyone understands how to solve these ones. All right, I'm going to get this one started for you guys, and then I'm going to see if you guys can work this one on your own. So to start with, line through our inequality, because we want to check, is there anything outside this absolute value bar? You should be saying yes, that there's a +4 that's outside of it. So we're going to move that over first. This has to be done prior to solving your inequality. So we have absolute value of 3x minus 3 greater than or equal to 6. Now that the absolute value is the only thing on this left-hand side, now we can split it apart into our two cases. So 3x minus 3 equals 6. And 3x minus 3 equals a -6. Notice as we're doing this one, we didn't change this here at all. We took 10 minus 4 to get the 6. And I did forget, because I know the answer to this one, I did forget to look that this should be a positive. If this 6 was a negative, we'd have to determine if it was all real numbers or no solution. And man, I can tell that I'm getting sleepy. I found one other mistake. I wrote these as equal signs. Super common to do. I've seen a couple people do that. But make sure that we have them as greater than or equal to. And on this one, because we have to flip the inequality sign, it should be less than or equal to. So don't forget those super common mistakes that happen with your absolute values. Here's what I would like you guys to do. I would like you guys to solve, whoopsie. I would like you guys to solve both of these and graph your number line. Like we did before, press pause and then press play once most people are done. I will show my answers and give you guys a few more instructions from there. So go and press pause and then press play when most students are ready. All right, so finishing this one up, adding 3 to both sides in case 1. So you know with 3x is greater than or equal to 9, dividing both sides by 3. So inequality sign stays exactly the same. So x is greater than or equal to 3. You can see my graphing here. And our other case is 3x minus 3 is less than or equal to a negative 6. Adding 3 to both sides, dividing by 3. X is less than or equal to negative 1. If you guys have questions, again, like we've done before, help each other out so that way everyone has an equal chance to understand the lesson. So here's what you guys are working on for the rest of the hour. First thing first, that absolute value worksheet is technically not due until Wednesday, but what I would do is I would take it home, do what you can, and then come Wednesday with any questions that you have from it. Come Tuesday with any questions that you have from it, and with any other questions that you have regarding absolute value. Some other things I want to remind you guys about, our Unit 8 test is on Friday on inequalities, and the Unit 7 end date is Friday as well. So make sure you have anything from Unit 7 taken care of from there. I expect the rest of the hour that you guys are on your very, 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 very best behavior, and I will be back tomorrow.